Here's a reminder about how to solve quadratic equations. My favourite quadratic equation is x squared plus 7x plus 12 is 0. And that factorises to be x plus 3, x plus 4. So then either x plus 3 is 0 or x plus 4 is 0. If x plus 3 is 0, x is minus 3, or if x plus 4 is 0, x is minus 4. Here's a quadratic equation that's similar to my favourite, but it doesn't factorise. So what we need to do is to use the formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. In this case a equals 1, b equals 7, c equals 13. So x is minus 7 plus or minus the square root of b squared minus 4 times 1 times 13. 4 times 1 times 13 is 52 all over 2a. So it's minus 7 plus or minus the square root of minus 3 over 2. Now the square root of minus 3 is not a real number, so therefore there's no real solutions. So how can we tell by looking at an equation whether or not there are any solutions? Well, the clue is in what's called the discriminant. The discriminant of a quadratic equation is b squared minus 4ac. In this case, a equals 1, b equals 9, c equals 5, so b squared minus 4ac is 9 times 9, that's 81. 4 times 1 times 5 is 20, so that's 61. Now, the formula involves the square root of b squared minus 4ac. If b squared minus 4ac is positive, which it is here, because we've got 61, then there will be two solutions. So if b squared minus 4ac is positive, then there are two solutions. However, if b squared minus 4ac is negative, there are no solutions. And then the other thing that remains is obviously what happens if b squared minus 4ac equals 0. Let's consider x squared plus 6x plus 9 equals 0. b squared minus 4ac is b squared is 6 times 6 minus 4 times 1 times 9, that's 0. Let's think about factorising this. It's x plus 3 squared. If x plus 3 squared is 0, that means x equals minus 3. So there's just one there's just one solution. So then we get this table. So if b squared minus 4ac is positive, there's two solutions. If it's equal to 0, there's one solution, and if it's negative, there's no solutions.